Cool. Okay. Welcome everyone to this optional mini workshop for your Flexi Week. Today we're going to be going through how to study for programming. When I say programming, what do I really mean? I mean subjects where the main focus is you learning a skill that revolves around a programming language, right? So in 1511, that's just introduction to programming in general, right? Of course, we use C to learn how to program as your introductory course, but what we go through today, so like the way we take notes, the way we study, that sort of thing can be applied to, I guess, any course that involves that more of a practical programming component, not just like your COMP1511, for example. So hopefully it's a bit of a transferable skill as you go through maybe your comp sci or software eng degree. And hopefully it helps you a little bit this term as well when you have to study for COMP1511 and then eventually your final exam too. I know something that I found a little tricky when I first started uni was that transition between going from quite heavily theoretical subjects towards a subject that was very, very application based, right? Of course, we do have maths and you would have had practice with subjects where it is quite skill based, but I think programming is a little bit different in the sense that there's still some theory and there's still a lot of application, but navigating how to write your notes and how to best study for it can be a little different to maybe just how you would do maths in high school or like a theory-based subject in maybe a commerce course or something similar to that. So hopefully this clarifies some things for you today. So what are we going to be going through? The first thing is how or if we should even be taking notes. The second thing is what to do when you get stuck. This is a big thing, I think, in most programming courses. I get stuck very, very often, and it's something that I think you just need to adapt to. It's very different to when you might have just gotten stuck in high school and you can go to your teacher or your friends and just be like, hey, help me out. You get things super quick and you move on. I think with programming, you get stuck, number one, way more often, and number two, in a bit more of an intense rut, right, when you get stuck. So we'll go through what you can do to kind of get through those moments where it's a bit rougher than usual. And then we'll go through how to study for exams. So I've just put a couple subpoints there that we're going to be covering, but there's a wide variety of things there too. We'll also have a bit of a Q&A, and you can, of course, ask me questions as we go. Yeah, feel free to pop anything in the chat, unmute, whatever you like, or what you prefer. Cool. Okay, so let's start off with note-taking. The first question I guess a lot of people might have is, should I be taking notes? And I want to start this one off with a poll and see how many of you guys actually take notes at the moment. So this is for COMP1511, by the way. So are you currently taking notes? I'll put that poll up now. You should be able to see that there. So just a simple yes or no if you're taking notes in the lectures or if you're not. No right or wrong answer here, guys, by the way. Cool. Okay, so we kind of have a bit of a split in terms of people who are taking notes and aren't. A little bit more towards the no here. When I started with 1511, as a student, I was definitely one who thought, oh, if I have a reliable set of notes, then I'll get through this course way easier. Sure, having a reliable set of notes can be something that can boost your confidence a little bit, and it's nice to have as kind of like training wheels when you're doing the labs and things like that, but it's really important to look at how you take the notes and see if, number one, what you're doing is efficient, number two, what you're doing is actually effective, and I guess number three, you're actually using the notes you write, because I found when I started 1511 at least, I did write notes, but I never found myself going back to them. And that's a bit of an issue, right? If you're taking notes and you're not using them, then it's just like mindlessly typing during lectures. So maybe we can have a look into ways that if you do want to take notes, ways it can be kind of efficient and effective. Now, not everyone is going to want to take notes, and that's completely okay. For people who who learn way more by practically doing things, you might not find having a set of notes useful at all. But for me and for people who are learning a new syntax, which is most of the people doing 1511, I think you might find having quite a small set of notes useful as you go through the course, but it depends on how you make them. So I'll just show you. This is what on the left my notes looked like when I did 1511. This is my very first lecture that I attended. I tried to think, okay, well, I used Google Docs in high school and for some of my theory subjects, so what I could do is just use Google Docs again, right? What would be the harm in that? But what I tended to find when I was using just a normal document type software was my focus wasn't really on the code that was being shown to me and the actual processes and topics, and I didn't really have an understanding of what I was typing. I was just copying down syntax, making sure I had semicolons in the right places, and not really focusing on the program itself. What have I transitioned to now? I've transitioned to Notion, or if you're not sure what Notion is, it's kind of just like a productivity app that lets you write Markdown, which is a way of formatting your notes in a way that's a bit more customizable and a little bit more efficient sometimes as well. Why did I make this transition over to Notion? Well, as you can see, probably the number one reason for me is these code blocks. So it allows you to do syntax highlighting, and it allows you to annotate code in a way that it's a lot more meaningful than just having like a square box with text in it, right? So when you write notes, your key focus, at least for a programming subject, should be on the content and the topic you're learning with annotations around it. For someone who doesn't own a tablet like myself, Notion is a good option, but this isn't your only option, right? So if you have a tablet, right, you might like to use something like OneNote or GoodNotes to annotate your notes. You might just screenshot lecture code and scribble around it. You could also make this work on your laptop if that's your preferred choice of taking notes. Some people even like pen and paper, right? So I guess the main point with note taking is you will want to have the focus of your notes be demos and code blocks where you can just annotate and explain them. And you'll find this way more useful later on when you're doing labs. And you've probably already seen this so far. I'm sure some of you guys, when you're doing the labs and you're doing a new topic, so say you just learnt pointers in the lectures, you've gone to the lab, and now you're being faced with a problem that you have to solve. A lot of you guys probably go to the lecture slides or the code demos that Andrew might do, and you might kind of model your solution to the problem based on an example that you've already seen. That's completely fine to do. But I find that this process is a bit more quicker if you do have some sort of a succinct note-taking version of these notes where you've explained what's going on in your own words. So this might just involve arrows pointing towards the code where you say, oh, return 0 just means my program exits successfully, something like that. And it can be a little bit more, you'll understand the code you're writing a little bit better than maybe if you just screenshot the code demo and add it to a set of Google Docs, and it's just a collation of somebody else's code that they've written where you don't really understand what's going on. Be careful though when you're writing notes. Don't just verbatim, of course, like repeat what the lecturer is saying. It really just needs to be a succinct version. Sometimes what I like to do is I'll watch a lecture, I won't write anything down, and then at the end of the lecture, I'll open up their notes and I'll just see what were kind of the key topics that they covered that were confusing to me or I didn't really understand, and then I'll go through, try my best to understand them and summarize them. If you can't summarize the content and you've just copied everything down word for word, it's probably a sign that you haven't understood it to the best of your ability. But we'll go through how to navigate learning the topics a bit better after this. So this is just a bit on note taking. I suggest Notion, but as you can see later on, I'll show you some other examples. They're on this slide here. Yeah, OneNote is a good example, GoodNotes, or even just a blank canvas. I've spoken to some tutors who say that they don't really like taking a large set of notes, but when they get really stuck on a topic and they do think that they need to make themselves a little bit of a cheat sheet for later on, then they'll just make a blank canvas and draw some diagrams that help them understand things a little better. So you can try that as well if that works for you and you're a bit more of a visual learner. And some people just like pen and paper, completely fine. You might prefer to do this. I tended to like doing this in tutorials when it was a lot more, a bit more problem solving mixed with kind of fast questions. I liked pen and paper for this. It also helps you to stay focused, right? Sometimes when we're on our laptops, we can get a little bit distracted by the notifications popping up everywhere. Pen and paper, if you're someone who easily gets distracted, is always a good option. But TLDR, anything where you can focus on the code is a good option. So when we saw that Notion example, we saw that the code is the main focus of this page, right? And everything around it is just kind of commands or annotations, right? Everything that you want to be annotating is the code demo itself. So this makes a lot more sense instead of this here on the left. Yeah, so I'll just show you, if you're wondering how to set up a Notion, there's templates that you can just copy off the internet. This is one that it's quite, I guess, aesthetically presented, but it just manages all of your uni in one place. You can use it for programming and other topics as well. So this one here, you might just link like your academic plan or web CMS, your tutorial link, anything that you want on the side, and maybe a playlist of some sorts. And then on the inside, you can have lecture notes. You can store them in a table with pages. I won't go into exactly how to use Notion and all of that today, because that could be an entire thing in itself. And there's plenty of people who have made tutorials on the internet and on YouTube you can find. But this link is there. All you have to do is click duplicate, and it will copy it into your Notion for you. If you want to see just some of the commands really quickly, this is my own Notion. You can set it on dark mode. It's what I use for my tutorials. But yeah, you can see the slash for commands. You just do slash and you can write code, and then it will open up a quick code snippet for you, and you can type whatever you like in here. So this is a comment. Yeah, so it's quite nice in terms of just quickly writing code and titles. There's a whole bunch of things you can do in here. So I would suggest, if you want to give it a play, see if it's for you. It's probably a good application to use for taking notes. But other than that, you can just stick with good old OneNote or GoodNotes. Just remember that the focus should always be on the code itself and not on, just copying everything the lecturer says or heavy paragraphs of theory that you're probably not going to use again. Cool. So that's pretty much everything I wanted to say about notes. Now we'll move on to what to do when you get stuck. And this will include how to best use these notes, right? Because there's no point having a nice set of notes if you're never going to come back to it. So we're going to look at three things today. We're going to look at experimentation. So this involves writing pieces of code that aren't really meant to solve one single problem. It's not like writing code to answer a lab question. You might use it when you do that, but it's more about you trying to figure out how something works by actually doing it yourself and not just Googling it. And I'll show you a demo of that too. Then we'll have a look at pair programming. So how do you actually do pair programming without one person just doing the whole thing? Because there's only one keyboard, right? So how do you actually manage that, and how do you get anything out of that rather than just programming by yourself? And then when to ask for help. So what should you do before? What should you do when you get stuck? And then what should you do after? Okay, making mistakes is really, really important. You probably remember a lot more of the mistakes you make than the things you do right. you probably remember the times that you get stuck on a certain bug in an assignment way more than you remember writing function after function, being correct and passing auto tests, right? So we want to utilize these moments where we get more stuck or we can solve a problem ourselves rather than outsource it or rather than go somewhere else because of memory, because it'll make you remember why something works rather than just, oh, I added a print statement here and now it suddenly works. Okay, that's great. I'll move on. You need to understand why. Okay, so we want to, number one, not be scared of writing wrong code or what seemingly might be wrong code. So that might be things like intentionally getting stuck in an infinite loop. Your computer won't explode if you get stuck in an infinite loop, right? But people are always kind of a bit scared to intentionally break a program because they think, oh, well, you know, it doesn't feel right. If I have errors and the terminal's screaming at me, it's not a great feeling. But the more errors that we read through and understand, the better we're going to be able to debug things like our assignments, right? So you want to know how something works and not just be copying it across from the lecture code to your lab to your assignment, and then suddenly you get to the final exam and you're not quite sure how to apply the skills that you've been taught. Of course, Google is still a great resource, and Stack Overflow, some of you guys might have seen, has a lot of, it's kind of like the internet's forum, not just the COMP1511 forum. It has a lot on it that can be useful explaining certain concepts, but what will be more useful for you is learning how something works yourself. So let's have a look at a small demo. Okay, I'm just going to open Vlab here. Cool. Should be up there. Okay, so what I've got here on my screen is just a program that is defining a new array and an increment integer and a scanned in number. So what it does is it asks the user for input. It says, hey, can you give me a number? And you'll store that one in whatever value you scanned in. That value is set to num scanned in. Now, if you've been watching the lectures and you're up to date with your tutorial and your lab content, you'll know that this integer value num scanned represents how many values scanf successfully read, right? So what do we expect? We expect 1 if we're wanting one integer number to be entered by the user. Yep. So then we're checking in a while loop. While num scanned in is not EOF and I is less than size minus 1, we will store that number inside of our array, and then we'll continue to scan until our array is full or we don't want to scan in anymore. Now let's pretend that I've just copied this from a tutorial or a lecture example, and I can run it. I can see if it works or not. Yep, so I might just say, okay, scan in a number 0, 1, 2, 3, 4. That looks like it works, cool. But why does it work? So I'm looking at the while loop, and a question that I might have is, what does this EOF actually do, right? So I've seen it around, I've seen it in the spec for the assignment before, and I know that it's probably going to handle some sort of user input, because when I run the program and I just hit Control D on my keyboard, it says done scanning in. So it seems to me that it breaks out of this while loop when I hit Control D. But what's actually EOF? Now, you could just go to the internet and you can just Google what is EOF. They'll probably tell you the answer. That's good. But maybe I want to find out what the value is myself. So I might just say something like, okay, what if above the while loop, I print the actual value of the EOF? I know this sounds a little bit weird, but if I can see what it actually does, maybe that'll help me a little bit better. So what if I just print F and I decide inside of here to put %d and then EOF. I might add a new line too, just so that it looks nice. Cool. And I'll add a semicolon there. So if I save that one now, and then I'll recompile this code. So called this one buggy code just because I can. Okay, cool. That warning, that should be okay because we have used the variable buggy code. Okay, so, all right, that right there, my -1. So I've scanned in the number and I've put the print statement after I scan in the first number. It shows me that EOF is actually -1. Okay, so if we're thinking now, well, we expect a value of 1, which is what we've been given. What if I just hit enter and I give it nothing? Nothing happens, right? So my while loop doesn't actually exit. It still waits for me to enter a number. And that's because EOF is -1. Right, so now what we can infer from our little experimentation is EOF is only going to stop my while loop. EOF is only going to stop my while loop if I intentionally break out of my program. So if I say Control D. Control D must have a value of -1, which gives EOF, right? So if I wanted to break out of the while loop, if I enter nothing or enter 0, I would need to change this again. And now I have a bit of a better understanding on how EOF works. Another place you can go to is actually the man pages. I'm not sure if you've had a look at them before, but this is the programmer's manual, which will help you explain, it'll help explain certain functions and how they work. So I've just hit man scanf, and what it's going to tell me is the different versions of that function. We only care about scanf in 1511, how to use it. So it's included in the hash include standard input output library, which is why we need this thing at the top of our program. Cool, so we can scroll through. We see a bit of a description. It says that it scans input according to format. That's nice. You'll see that a lot of this is very long and hard to read, so you'll skip through it quite a lot. It'll tell you what types of formats you can use as well, and conversions. It gives you what the % means. So yeah, it'll tell you a lot of things if you want, and on the return value. So I might be interested on the return value, right? Because that's what I'm comparing to EOF. It says on success, these functions return the number of input items successfully matched and assigned, and the value EOF is returned if the end of input is reached before either the first successful conversion or a matching failure occurs. Okay, so we have even more information now about it, and we can be sure that EOF refers to when we exit the input or exit the program. And you can just click Q to exit out of that man. So you can do that all in your terminal without even going to Google. So I didn't go to Google once, and I found out what EOF is. Cool. So some other things that we might want to experiment with is if this whole time you've been writing int before your variables and you have no idea what that does, just remove it. Remove it, run your program, read the error, and see what it says, right? You'll learn a lot more doing this than just still copying and pasting the code over and over without actually knowing what it does. Or what about the increment? What if we got rid of this? So I might just do this one, get rid of the increment. Cool. And then recompile my code, ignore that warning, and then rerun this. So if I just scan 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, what's happening? Well, it's letting me keep scanning, and it hasn't given me an error. I know that if I've defined my array size of 5, if I went past this, then I would get an error, right? I would get an error that says something like, you've gone past the end of your array, you can't write into this memory. So what's probably happening here, because I haven't incremented, is it's just writing in the value of 0 over and over and over. So it's just replacing the first element of my array infinitely, right? So that might help me understand how this loop's actually working a lot more than maybe if I just copied the code and didn't understand it. So that's a couple things. Now, I would suggest you do this for assignments a bit more so than just labs, or anytime you don't understand content. Just try popping in a bunch of different print statements, a bunch of different alterations. Even if you think it's going to break your code, intentionally break it and see what happens, right? It's not a bad thing to get errors. People always think errors equals bad, but errors to me equals learning, right? So you want to practice, you want to do this until you try and find every possible mistake and error you could make. So when it comes to things like assignments and labs, you aren't making as many mistakes as maybe you would if you haven't seen the errors before, and you'll be able to debug them quicker and move on, which is really critical for exams, especially programming exams. You don't want to be seeing an error for the first time in an exam. So it's really good to get comfortable with errors. Be comfortable with seeing them and be comfortable with intentionally creating them. Cool. Okay, so the next thing I want to cover is pair programming. So how do we use this so that it actually helps you learn? Yeah, so what I tend to say is the first thing you should do is one person in this pair is going to be dictating in English what the code should do, kind of what you might call like the algorithm, and the other person's going to be translating that into syntax. So what we might have is I would be sitting here and say, maybe just create a while loop that only loops 10 times, and the person will go, okay, let me set that up, and they'll just write while I is less than 10 and then set up with the curly braces. And then I would dictate and say something like, okay, so if we want to print the numbers 1 to 10, I'll write printf, and then I want to print a number, so I'll use something like %d, and then I'll put in my I value, whatever I'm up to. So you can see how I'm explaining that. I'm not saying type while space bracket, then your condition, and then curly brace, right? Then people aren't learning that way. But if we dictate in English how we want the program to function, number one, it helps you clarify your thoughts. If you're the person dictating, you can kind of have a better overview of how the algorithm should look without messing up little bugs that are going to stop your flow. And if you're the person typing, you get an insight into, number one, how another person thinks, right? Because you might think about a problem in a different way. You might not think about it from a high level where they're thinking about loops first and then something else. You might be thinking about, well, if I have to do a calculation inside of my while loop, maybe I should be writing this in a function first, somewhere differently. So getting an insight into how different people think when they program is really, really helpful, and it will help you think about things very differently as well. Especially with programming, you do have to have a bit of creativity when you solve problems. One solution's not going to work over and over and over. So you need to be able to swap your methods and adopt different approaches very easily. And I find that pair programming gives you that perspective that's a bit more broader than maybe just what your tutor, lecturer, and yourself can do, right? Because different people think in different ways. How do you do this if you don't have someone to help, right? Because we can't always pair program. So if you're stuck in a final exam for 1511, or you're stuck in your assignment, which are two things that you can't pair program, so just to give you an FYI, right, that's plagiarism and it's against our misconduct rules if you are to pair program in an exam or an assignment. But you can pair program for some labs if you want to, and for any other challenges or study that you do online. Now that it's COVID lockdown, you'll probably be doing this online. But yeah, you just don't do this for exams and assignments. But what do you do when you can't do this, right? How can we adapt to this approach so that you can use it for your exams and assignments without including another person? What I suggest, and what a couple other tutors suggested as well when I was making these slides, is try to pair program with yourself. So what does that actually look like? Break up, see how there's two steps here, like the actual problem solving bit and the translate into syntax bit, split them in two. So you might want pen and paper for this, and you'll sit down and you'll write, okay, so if I want to figure out which years I input into a program is a leap year, maybe that's what you want to do, which was a previous lab we had. You might sit down and write, okay, what would my algorithm look like if I was to check a leap year? And you might do a bit of research if you're not sure, and you find that you might need to divide a number by 1,000 or by 4,000 or something like that. Write down those steps. So check if something else, and write it down with actual English. And then, kind of like how you would dictate it to someone, right? Then you translate it into programming syntaxes, because there's mainly two types of errors when you're solving a problem. The first one is a logical error. So you actually not understanding or not having the correct solution to the problem. So maybe you're missing an edge case where you're not checking if you should be dividing by 1,000. You're only checking by 4,000. So that's the first error, the logical error, and that's just based on your problem solving alone. The second case of errors is your syntax errors, right? So that's forgetting a semicolon or forgetting opening or closing braces, something like that. When you split up these two components, your focus isn't constantly swapping between writing logic, fixing syntax, writing logic, fixing syntax, right? That swap can get very, very confusing, especially when you're solving really hard problems. So try split it up. Even if this just looks like, if you don't have pen and paper for every lab, write a couple comments at the top of your file and just write something like, I want to check XYZ, and then write the code for it underneath. You'll find that you'll make a lot less errors, and you'll probably quicken up the pace of how you can solve problems and how you understand the content as well. It's almost like, if you think back to maybe HSC, when the teachers told you to plan your essays first, right? Give yourself an overview of what you want to write about before you actually jump into writing about it. It can be really useful if you have some sort of a plan or an attack approach before jumping into, especially with problem solving and programming combined. Yeah, so try your best to do it yourself when it comes to assignments and things like that. If people aren't free to pair program with you and you want a bit of practice on a certain topic, I would suggest going to the forum. So you'll find there's so many questions on there that students post, and you don't have to be a tutor to respond to them. It's really useful for you to sit down, look at someone else's problem, maybe look at a code snippet, try solve their problem, and respond to them and say, hey, what if you try this? Or have you considered this approach? Why is this useful? It actually exposes you to more errors, which is what our previous point was, right? With experimentation, you're kind of getting inspired by other people's experimentation. It helps you teach someone else a topic, and when we teach anyone a topic, then we naturally get better at it ourselves, because we have to formulate the topic and say it in a way that's easy to understand. So we can't say the topic, and we can't present a topic that's easy to understand if we don't understand it ourselves first, right? So it's a good check to see if you understand something. Don't be scared if you get something wrong on the forum. A tutor will obviously look through the posts as well and help you out too if you missed something in your response to someone. But yeah, it's a really good way for you to revise as well. So I would suggest it's kind of pair programming. It's kind of like an asynchronous pair programming when you use the forum. So you can give that a go as well. It doesn't have to always be in person or over Zoom or Discord or anything like that. But that can obviously help quite a lot. Cool. Oh, okay. I think I went backwards. Yeah, okay. The last one is asking for help. So this is something that I think I struggled with the most in my first year, but I'll be honest, I still struggle with this quite a bit now, right? And I don't think you should be ashamed of either A, struggling with it, or B, asking for help. But it's something that it's hard to kind of realize when you should be going and seeking external help versus when you should maybe just spend another 30 minutes on the problem and see if you can solve it. So how do you find this, I guess, optimal time to go and ask for help? I like to ask myself, have I spent time not just attempting the problem, so say not just doing the lab question, but actually understanding the underlying concepts? So even yesterday, I found myself guilty of this. I was trying to do a lab question for a topic that I'm currently doing, web security. And I was just kind of keyboard mashing a bunch of different things. I was trying so many different commands, getting so many errors, and I was thinking, why isn't this working? Why isn't this working? I was going to Google, searching up so many different things, copying and pasting them, nothing was working. And then I kind of took a step back after like a good 30 minutes of doing this, and I asked myself, do I actually understand what I'm writing here? Do I understand what's happening? Or am I just trying things and just hoping one's going to work? I found it was the second option. I was just trying things and hoping it would work. So actually after this talk, what I intend to do, because at that point I was frustrated and annoyed, so I just put it away and moved on. So taking breaks is a really good thing to do as well. Like if you're stuck, just take a break. When you realize you don't understand something, don't immediately try and swap over to problem solving and go on and on and on the same problem. You won't get anywhere. So just take a bit of a break, even if it's a whole day, and come back to it, but come back to the concept, not the problem. So you might need to revisit your notes. You might need to revisit the lecture if you didn't pay attention, or ask a friend and say, hey, do you understand this? Would you be able to explain this to me, or something like that? You might experiment with the concept a bit first, understand it, and then go back to solving the problem. So if you've done those things, if you've given the problem a crack and you've tried to understand the concept, and either you just don't really, you can't wrap your head around it, or you think you know it, but it's still not working, that's when you ask for help, right? Because this is the point where you either are misunderstanding an important bit of theory, or you just haven't had someone explain it to you yet in a way that makes sense for you. So this is when you ask for help. Also, stress, frustration, any type of emotion that's beyond just, I guess, tiredness from trying to answer questions, that's also a sign to either ask for help or just take a break, right? Every time I try and work on a problem and I'm frustrated or I'm stressed, it takes me like 4 times as long to do it than if I just take a break and if I come back to it with a fresh mind, especially when it comes to bugs. If you have a bug in your program and you can't really figure out what it is or where it is, putting it aside for a bit, doing something else and coming back to it, you'll probably be able to spot it a lot faster. You probably did something like this in maths, maybe in high school, when you saw a problem, you really couldn't solve it, you just got stuck there for ages. You took a break, you came back to it, and suddenly you had a fresh idea to try. So give that a go too. And the last thing I want to say is feeling not good enough isn't ever true. So don't sit there and think, oh, the reason I don't understand this is just because I'm not good enough, or I don't understand what's going on, and this course is just too hard for me, and everything's going too fast, and I'm just not up to date. And don't end up in that spiral, right? It's easier said than done, right? It happens to me all the time. But something that's good to remind yourself is just everyone is at different stages in their learning journey. If you don't understand something now, you have time, you can understand it, you can ask for help, and hopefully you'll understand it in a couple days or a couple weeks or even a couple months, right? It's really nice to look back on how far you've come as well. Most of you probably never wrote a C program before this course, and now you're learning pointers. I don't know about you, but before I did this course, I had no idea what a pointer even was. So looking back on your progression is really important too. Of course, the kids that have written C since they were like 4 years old will know what a pointer is. I'd expect them to be able to do the week's lab on pointers quickly, right? Because they've been using it, they're used to it, and they've had a different learning journey. But if you've just found out what they are 2 days ago, don't expect to be able to keep up. So you shouldn't compare yourself as well, right? So don't be scared to ask for help. Anytime you feel an emotion that's a bit beyond just, writing solutions to things, ask for help, okay? As long as you've given it a go first. Where can you go? Ask friends, as long as you're not in an exam or you're doing a weekly test or it's an assignment, you can ask your friends. Ask on the forum, ask your tutor as well. Attend help sessions. There's so many running this week, guys, so you have heaps of options. If you're not sure where to find the schedule for that, that's on the course homepage. Watch recordings of tutorials or past lectures. If you don't understand how Andrew explains something or your tutor, you can watch a recording on Blackboard or go to the COMP1511 YouTube page, and Mark Chee's old lectures are all on there. They're all still valid, right? Sometimes because you didn't understand something, it's just because you haven't heard it in a way that works for you yet. Yeah, so maybe your tutor, the way they explain pointers, it just didn't work for you. Go and seek out other explanations. We have so many resources that you can use in 1511, so just abuse it, right? As a student myself, I watch multiple tutorials when I don't understand something. Some tutors' explanations click for me and some just don't, and it's okay. I can swap between tutorials, and as long as I go to one, then I'm learning, right? And I'm learning in a way that works for me and not just going with the flow of things. The other thing you can do is use unofficial course chats like the CSE Soft Discord, or I'm sure you guys have like a messenger chat of sorts. Just keep in mind this is unofficial, so any responses you do get aren't like 100% the right thing to do to solve your problem. Because if you ask on the forum, we can get tutors to respond who can see your code and give you like personalized responses. So you're probably better to ask on the forum, but if for some reason that doesn't suit you, perfectly fine. You can ask friends or Discords, or even at CSE Stock events like study sessions and things like that. You can attend those and ask for help too. Cool. Okay, so let's have a look at studying for exams then. We're coming back to using your notes. So we made notes throughout the term, or maybe you made notes, which were just kind of these little annotations on the lecture notes and the core theory topics, the important things that you think you might forget, or you want to write your own explanations for as you learn the content. How do we use them? So what I like to do is I like to make cheat sheets. So I'll sit down at the end of learning, maybe at the end of learning arrays in its entirety, and I'll ask myself a couple key questions, and I'll try and make up a cheat sheet. So I'll see, can I define what an array is? Do I know what it's used for and why we use it over just a bunch of variables? Can I define an array? Can I change elements in an array? Can I write a couple basic functions that do things with my array, like scan in elements and set elements, or loop through an array and print them? Do I know how to use 2D arrays? So I'll write those things down also in like a Notion document. And if it ends up being a nice, short, succinct length that would be perfect for something like a cheat sheet, then I've probably understood the topic well. This can be extremely useful to have when you're doing labs, as like kind of like training wheels next to you while you write solutions to things, because you can look over and you go, oh, right, that's the syntax for initializing an array. I remember now. It's really quick, it's fast, and it's in your own words, so you know where to find things. I've got a couple samples that I'll show you on the next slide, and I'll link you a Google Drive with those cheat sheets too, so you can kind of format yours similarly. But I would always suggest making your own, because the point of it's not to make the actual cheat sheet. The point is, are you able to synthesize everything you've learned about a topic into a very short, readable paragraph? If you can, then you probably understand the topic well enough that you can start attacking really hard problems. Practice makes perfect. Probably the biggest piece of advice I can give. So when we were talking about experimenting, intentionally breaking programs, redo tricky questions. And like, I'm sure maybe your math teachers told you this in high school, but when they said things like, redo a question, but with a different approach. Try solve it a different way. Don't just solve it the way you always do. This helps you think creatively when you problem solve. So redo questions, but try to do them differently. Maybe see if you can write the code in a way that's neater, or using things that you've learned from newer weeks in a lab that was like quite old, right? So you can try that too. You can Google search for topics and your language. So you might write C pointers practice questions and just use some on the internet if you need a little bit more practice beyond what we have right now. We'll also give you practice questions before the exam. We'll give you a sample paper and a bunch of revision questions that I 100% recommend you do all of them, because it's fantastic practice. And you really want to be spending like 80% of your time practicing and only like 10 or 20% of your time going back and revising your topics, because you should be keeping up to date with those week to week. Flexi week, this week, perfect time to catch up on the previous weeks of content if you're a bit stuck with certain topics, especially pointers. At this point, I think for me at least, I was pretty confused with pointers because they were pretty new. So I did spend quite a bit of my flex week going over it, writing better notes, trying some questions beyond just the lab stuff, and actually understanding things so that I knew what I was doing when I did my assignment. And yes, separating the programming part with the problem solving part, same advice as I gave before. Do this in your exam as well. You won't be wasting time if you spend an extra couple minutes thinking through your logic before you write out the syntax. The tricky thing with programming can come when you use either the wrong approach or you have a weird bug, like you forget a semicolon or something, and DCC isn't nice enough to tell you, hey, you forgot a semicolon. Sometimes those bugs are extremely hard, and you would rather just have a longer process for answering the question rather than double the time it takes you to debug and pass the auto tests, right? So it's just about redistributing your time, being patient with yourself, really, and allowing yourself to problem solve before you program. And group study still works. Pair programming, give it a go with the revision questions, or if you didn't try some of the challenge labs, because trust me, some of them are hard, maybe give a couple of them a go with your friends. Say, hey, does anyone want to try decimal spiral with me, right? And you might sit down and you might think through the logic together, because it's a lot harder of a question, before you tackle the programming, and then maybe go into programming together and see if you can solve it. It'll be a lot easier when you have other brains to use as well as your own, and you'll learn from how other people think too. Obviously, we still have Discord and Zoom. The CSE Soft Discord's a useful one. We have group study sessions on there too that I think they're every week or bi-weekly now, that you can hop on them, and I'm sure you'll find other 1511 students there if you don't have anyone to pair program with at the moment. Or just ask people in your lab. More often than not, especially online now, people, if you say, hey, to the tutor, can you make another breakout room and me and this person are going to jump in and try some pair programming, I'm sure they'd be more than happy to help you out with that too. And you'll probably get through the lab quicker than maybe what you would ordinarily do. So who doesn't like saving time? Cool. This is an example of some cheat sheets. You can find them in this Google Drive, and I have a bit.ly link to these slides at the end that you can look at and then get the link through there for this and both the Notion template. So this is kind of that example that I was talking through. You do not need to make them this aesthetic. We only made them this aesthetic because it was for like CSE, so it's for everyone. But if I was you, just Notion dot points is so fine. Don't bother wasting your time making them this pretty. Unless you really want to, then go ahead. I'm not going to stop you, right? So yeah, just defining what it is, an example, what the purpose is, creating it. And then after that, after this quite short cheat sheet, that's when I would go and do the practice questions. keep in mind, this is just what worked for me in particular. You might hate this idea of a cheat sheet. You might just want a blank canvas, draw some sketches of how you think an array works just to make sure you understand what's going on, and then you might go into practicing stuff. Or you might just jump straight into practicing, and you might not mind being interrupted every now and then, realizing you don't understand something, and then going back to your resources and then jumping back to your practice questions. For me, as someone who doesn't like to break their focus as much, I like to kind of revise everything first and then jump into the practice and dive deep, knowing that I'm pretty sure I understand most things, most of the basics at least. Of course, you'll still have to interrupt yourself every now and then, but that just helped me, especially with brand new concepts. But yeah, it's not like a massive set, 80 pages of notes, which you might have for other content-heavy topics. It's quite short, it's quite succinct, and it's using your notes that you've written effectively, because you can base this cheat sheet off your notes if you don't remember certain things. Cool. That's everything that I wanted to cover today. Does anyone have any questions about notes, about studying, about 1511 studying, any questions for how I did things or other subjects? Feel free to put them in the chat now if you do. Where can we get these slides from? This bit.ly link here should link the slides, so you should be able to get them. Yeah, the recording is going to be available on, I believe, the 1511 YouTube channel, but it should also be available on Blackboard after this too. So if you need to go back to anything, you can, or if you came a bit late, perfectly fine. Yeah, so that bit.ly link that's on the screen right now has the link. I'll actually also pop a link in the chat. This should send you guys to the Canva presentation as well. Any other questions? Otherwise, I might just stop the recording here. Okay, we've got a couple. For people new to coding, it takes a lot of time and practice. How do you divide your time on practicing comp and still balancing other uni courses? That's a great question. So especially as someone who started in 1511, having never touched a C program before, what I liked to do was I didn't speed up any of my lectures. I know, controversial, I still don't for most lectures unless I'm in a terrible rush, but it's very rare. I watch my lectures at normal speed, and I also like to watch them live. Why do I do that? I can ask the lecturer questions if I need to throughout, and I absorb the content at a nicer speed. If you're someone who this is maybe a bit too fast, again, watch it back, but allow yourself to pause it, take breaks, and that sort of thing. But I find that watching the lecture in the 2 hours, I learn the content better than watching it back at a faster speed. And then what I would do is I go to my tutorial. That's when I try and remind myself what I learned in the lecture. Spend the 2 hours. What I like to do is kind of set up my approach for practicing, right? So I will pretty much just go through and try my best to answer the lab questions. But if I can't, I'll take a break and then probably that same day answer them again, like try and go through and finish them up, or fix up my responses to certain things, or like, my solutions. So in total, I would say go to your lectures, then another hour maybe to just wrap your head around topics I would allow. So if you've got two 2-hour lectures for 1511, that's 4 hours, and then maybe another hour where you're just self-learning in a way. Then you have your tute hour, which is another 1, your lab hours, which is another 2, and then maybe another 1 or 2 hours for practicing. So around 8 to 10 hours a week is probably what I would say is a really good amount of time to devote to 1511, given you have other subjects. So for example, in week 6, when you don't have lectures and things like that, perfect time to just smash out your assignment. Yeah, so it can be hard to balance, but just making sure that the time you do spend on comp is very effective and you're not wasting time, because I think when people watch lectures at too fast and they don't understand what's going on and then they have to go back to it, that's a bit of a waste of time. That's probably how you're going to be the most efficient as you can. What's the difference between 1521 and 1531? Very different, actually. 1521 is a little bit more what I would say low level, so it's focusing on how does code actually run, almost how assembly works. So you can give that a Google. I think the official name for it is like computer systems, something like that. And 1531 is the opposite end of the spectrum. That's software engineering fundamentals. So 1531 is like, how do I work in a team to produce a big project? Almost how you're going to work. If you're going to become a software engineer, it's how you're going to apply what you've learned in 1511 in the real world, that kind of thing. Is it good practice to have good code style as you code or fix it up after auto tests? That's a good question. I would say that having good style will help you debug, right? So if we're thinking about that process of writing logic, writing syntax, and then going back and fixing things up, I would say 100% it's better to have good code style as you code, because it makes that debugging syntax process way quicker, right? So you'll be able to spot your errors better than writing a program, realizing there's errors, fixing the code, rerunning it, then looking through the errors again, right? Just saves you that one extra step. Work-life balance, really good question. Keep your uni time on a schedule in a calendar. So I like to have it in my calendar scheduled for those times that I mentioned, like that breakdown for that Darren asked. I like to keep that in my schedule. And then I also like to schedule in around at least 3 hours a day where I'm doing something that is not coding at all. Some people love coding and we want to do that with every moment of their day. But for me, that's not it. I need breaks. So if that is going outside and going for a walk, if that is jumping on a Discord call and playing board games with my friends, if that's cooking something, if that's like listening to music and just kind of chilling for a bit or reading a book, find times, and I would say at least 3 hours spread out in your day, so it doesn't all have to be a 1 3-hour chunk. Just spread it out a bit. Use it whenever you find yourself getting a little bit emotionally invested in your work, right? And I don't mean in a good way. I mean in a way that's like either stress or frustration or anger or anything like that. You'll be more efficient if you just put it away for a bit, take a bit of a walk, and come back to it refreshed, especially with programming. Because when you get frustrated with a piece of code, your brain, you just become like tunnel vision, right? You see one thing and you can't really do anything else, and you're just locked in this bug, and then you start thinking, oh, why am I not good enough to just solve this thing? It's so simple. That's when you take a break. Oh.
Could you try again?
Oh my gosh, Siri on my watch. Text editor of choice. I like VS Code, but that would be probably another talk that someone would want to give this week on text editors. But in 1511, you guys use Vlab for most things. Cool. Any other questions? I might wrap it up here if there's nothing else. Cool. Thanks for coming along, guys. I hope you found this useful. If you've got any suggestions for other things that I didn't talk about that you think I should have, feel free to ping me. You can find me, I guess, Facebook, LinkedIn, or my email through the course if you're doing the course. Yeah. Otherwise, I hope you guys have a good afternoon and get something useful out of this. Thanks, guys.